So for this video, we are going to review forces and circular motion. If you have the note sheet, you should pull that out. If not, I recommend that you go to the website and print out the PowerPoint. That way you can follow along and you can also take notes as you go. That's the way you should be treating these videos as you watch them. You should not just be sitting there passively waiting for the questions. You should be taking notes as you go. So also make sure that you have a pencil and a calculator for sure, because I am going to ask you math questions throughout this video. Alright, so the first thing we talked about when we started forces are Newton's laws. So we had 3 laws that we discussed. The first law said that a body at rest stays at rest and a body in motion stays in motion until a force acts on it. Basically, this whole law is about inertia. Inertia is a property of matter that resists changes in motion. And mass is actually a measurement of inertia. So the more mass something has, the more inertia it has, and that makes sense. The heavier something is, the harder it will be to push it to get it to start moving, or to stop it when it is moving. Now, the second law, mathematically, is force is equal to mass times acceleration. And you can also say that mass and force are directly related. So as mass increases, your force would need to increase to move it. You could also say that acceleration and force are directly related. So as the acceleration increases, the force would increase. So basically, if you're pushing something harder, you're going to accelerate at a faster rate. You could also say that mass and acceleration are inversely proportional. So that means the heavier something is, the less it will accelerate. So if you have something that is heavier, it's going to be harder to move it. So if you want to get it to accelerate at a certain rate, you're going to have to apply more force. So as the mass increases, your acceleration in general should decrease, but it will depend on how much force you're applying. And our third law deals with action-reaction pairs. So for every force, there is an equal and opposite force. So basically, if you punch a wall, the wall will punch your hand back with an equal and opposing force. Alright, so when we're talking about force, we will often have to look at the net force. So anytime that you're solving for acceleration of an object, you have to use the net force. That is the only way to get the acceleration of an object. So whenever you're given a problem and it's asking for the acceleration, you need to figure out what forces are being applied to that object, and then figure out the net force. So if you have 2 forces that are opposing, so I have a box right here, and I have a force going this way and a force going this way. If they are opposing like this, you will subtract them, and then if they are working together, you will add them. So if I had 2 forces like this pushing on the object going in the same direction, you would add them together. Now, when an object is in equilibrium, the net force is equal to 0, so there is no acceleration. And this will happen in 2 different situations: when there's a constant velocity or when the object is not moving. So if you read in the problem where it says you have a constant velocity, that means your acceleration is 0, so the net force has to be 0. When this happens, all your opposing forces will be equal to each other. So right here, if this box was moving with a constant velocity, this force and this force would actually be equal to each other. So you can have movement and have a net force equal 0, but you can have equilibrium if an object is moving. And I think a lot of students miss that fact. So this is something that you might want to highlight in your notes. Alright, so the main types of forces that you want to look for are going to be weight, and weight is going to be important if you're moving an object up or down. So if it's moving up or down, if it's hanging, so if the object is hanging, the weight's going to apply here, and also when you have friction. Okay, the normal force is the force that pushes back on an object when it's sitting on it. The normal force is going to be perpendicular to the surface. So if you have a surface like this, the normal force would be pointed up like this. But if you have a surface like this, your normal force would be like that. So remember, it's always perpendicular. The force applied could be something that's being pushed or something when it's being pulled. Force of tension applies when you have ropes and something is being pulled. It's basically a pull. And the force of friction will happen when you have surfaces rubbing on each other. Or a sliding motion. So when you have a sliding motion, there will be friction. So if you had something hanging on a rope, there is no friction with that. But if you move something across a surface, there will be friction. Also, you need to realize that there will be no normal force if it's something that's hanging on a rope. Okay, so weight is something that we cannot forget about. You will get the weight by multiplying the mass to everybody's favorite number, 9.8 meters per second squared. Do not make this number negative though. So what is the weight of a 40 kilogram object? So if I wanted the weight, I would take 40 kilograms and I would multiply it by 9.8 meters per second squared. This is really just using the formula force is equal to mass times acceleration. It's just the acceleration that you're using is this. So when you get this, 40 multiplied by 9.8, it's roughly going to end up being 400. And this is kilograms, meters per second squared. So that is actually newtons right there. So something you might want to go ahead, write that in your notes. A kilogram times meters per second squared is 1 Newton. So yes, it's a little bit rounded here. That's okay. All right, so what is the force applied on a backpack that is being moved up at a constant velocity that has a mass of 10 kilograms? So this is a good problem. It involves a lot of different things here. So we have an object that is being moved up. So I have some force pushing it up. Well, if I have some force pushing it up, if the object is moving up, so I need to think about the weight, or the force of gravity. So it also tells me that it is being moved at a constant velocity. So that means there is no acceleration, which means the net force is equal to 0, which means that the opposing forces are equal to each other. All right, so if I want to know what the force applied is, I need to know the force of gravity. I know the mass of the object, it's 10 kilograms. I also know the acceleration due to gravity is 9.8 meters per second squared. So I'm going to get the weight first, and then once I know the weight, I know the force applied. So my Fg, or my weight, is equal to 10 times 9.8. So Fg is equal to 10 times this. Oh, 98. 98 newtons or kilograms meters per second squared. All right, so the force of friction. You have to remember that the force of friction happens when there is sliding motion along some sort of surface. So the force of friction is special. It has a unique formula. You can still get the force of a force by multiplying mass times acceleration, but when we're looking at just the force of friction, you can also take the coefficient, which is this funky u right here, and multiply it to the normal force. Now this is the formula, but really the normal force is equal to the weight of an object on a level surface. So if it was on a ramp, this would not be true. If it was on a ramp, you'd have to look at your x and y components. All right, so you have two different types of force or friction forces. You have static friction and kinetic friction. Static friction happens when the object is not moving. So you might be pushing on an object trying to get it to start moving, and that would be static friction. And then kinetic friction is when you are actually moving the object across the floor or across the surface. Now, your kinetic friction will always be smaller than the static because it is harder to get the object to start moving than it is to keep it moving. All right, so solve for the coefficient of friction when an object is moving along a surface with a constant velocity that has a weight of 50 kilograms and the applied force is 50. So when we're looking at this, let's draw the object. I have a force applied, pushing the object, and that is 50. And then I know that there is a force of friction that's opposing it. So I'm looking for the coefficient. I know that the force of friction is equal to this. And I also know that it's moving along with a constant velocity. Since I know that, the acceleration is equal to 0, the net force is equal to 0. So that means that the force applied and the force of friction are equal to each other. So I know that my force applied is 50, so my force of friction is also 50. I also know that my normal force is the same thing as my weight. So it says that it has a weight of 50 kilograms, and that should not be that. It should be 50 newtons. So my weight is 50. So I have enough information here to solve for my coefficient. My force of friction is 50. My coefficient is unknown, and my weight, or my normal force, because it's the same thing on a level surface, is 50. My coefficient here is 1. And this is actually a very large coefficient. All right, so the force of gravity is another very important force, and the force of gravity has its own special formula. And basically, the force of gravity is an attractive force between two objects that have mass. So if we talk about the force of gravity on Earth, you're really talking about the two objects being yourself and Earth. So when you solve for force of gravity, you use this equation, and big G is equal to this number, 6.67 times 10 to the negative 11. And this is a constant. It will never change. It's a very, very small number. So you compare the two masses of the objects and also look at the distance in between them. So if the distance increases, so if the objects are further away from each other, so if r increases, that means the force of gravity will decrease. And you can tell that these two items, the force of gravity and the distance, are inversely related because r is on the bottom of the equation. Now, if mass increases, then the force of gravity increases, and the opposite would also be true. You can tell that these two, that the mass and the force of gravity, are directly related because mass is on the top of the equation. All right, so what is the force of gravity between Splat the cat and the person that is 50 kilograms when they are 1 meter apart? So the cat and the person are 1 meter apart, and you're looking for the force of gravity. So you want Fg. You know that the mass of the first object is 1 kilogram. Mass of the second object is 50 kilograms. The distance is 1. So I'm going to plug it times 10 to the negative 11th newtons. Or if I was going to write this out properly, I would say 3.3 times 10 to the negative 13th newtons. All right, so if you're given a question like this, you can just simply plug it into the formula and then solve. All right, so if the force of gravity is originally 10 newtons, what happens if the distance is halved? So you will definitely get questions like this where it's asking you to basically look at the equation and decide what's happening to the original variable. So if the original force is 10 newtons, you need to decide if it's going to increase or decrease first. So if the distance is halved, that means that the objects are moving closer together. So if they're moving closer together, the force of gravity should be going up. So it's going to increase by a certain number. So if the distance is halved, that means that it was reduced by a factor of 2. So that means that my force of gravity is going to increase by a factor of 2. But if I look at the equation, the distance is squared. So I take the factor of 2 and I square it, so I get 4. I know that my force of gravity is actually going to change by a factor of 4. So it's going to increase by a factor of 4. So I'm going to take my original force, multiply it by 4 to get 40 newtons. All right, so the last thing that we're going to talk about is centripetal force. Okay, so the last thing we're going to talk about is centripetal force. And centripetal force happens when you have an object moving in a circular path. So first thing, if you have something moving in a circle and you need to find velocity or acceleration, you're going to use these equations. So vt, the little t, is just for tangential velocity, which means that it's moving in a circle. And r will be the radius. So r is really the radius here, not the distance. And then t is going to be the period. That's the amount of time that it takes for, so basically the time it takes for one circle, or for one complete cycle. Okay, so if you have something that's moving in a circle, since velocity is a vector, the velocity is constantly changing because the direction is constantly changing. The speed might not be changing though. All right, so centripetal force is really not a new force. You would still take the mass and multiply it by the acceleration. You just might need to find the centripetal acceleration though. Okay, so friction, gravity, and tension are all centripetal forces. So if you're moving in a circle, it's going to be one of these three forces that is actually causing the object to move in a centripetal or move in a circular fashion. So friction happens if you're driving or riding a bike, gravity happens if you're orbiting, and tension is if you're swinging something around in a circle. Most important thing is that centripetal force is always directed towards the center. Always, always. All right, and that concludes our review on forces.